Daniel Junius wants to know what happens when we fall into a black hole.
Ooh, you want to avoid that, first of all. Don't do that. Neither at home or at work or anywhere else. But if you happen to fall in a black hole, which is my preferred form of death, it's better than getting hit by a bus, right? So if you fall in a feet first dive to this cosmic abyss, you will not survive because you will not miss. The tidal forces of gravity will create quite a calamity when you're stretched head to toe. Are you sure you want to go? Those tidal forces will increase to the point where your body will just snap in two, likely at the base of the spine. Then each of those two pieces will snap into two. So you become 1 to 2 to 4 to 8 to 16 until you bifurcate all the way down to the center of the black hole. And you become a stream of atoms. And that's not even the worst part. The worst part is you are funneled, extruded through the fabric of space-time, so that you used to be this wide, now you're this narrow. And so this phenomenon, this extrusion like toothpaste through a tube, we have a word for it. Death by black hole is called spaghettification.
Spaghettification sounds like a meal to die for. See what I did there? Kill me.
We see all this activity in the center of the galaxy, stars orbiting a big dark area.
Right.
How do we know it's not just like the center of a hurricane? And the reason why we know that is because what we learned from Kepler and later Newton is the orbit that you have is the speed of your orbit is completely determined by the mass that's sitting inside your orbit. The mass around which you revolve.
Right.
So what you say is, here are these things, I can see how fast they're moving, run back to Kepler's equation and say there must be a mass, a huge mass, like bigger than the size of the orbit.
Wow.
Wait, and then you say, but wait a minute, we don't know anything that's that massive, that's smaller than the orbit, except for a black hole.
Gotcha.
Okay? So in other words, if it was a star with that much mass, it would be huge or
right.
some other thing, and you'd see it.
You'd see it, right.
You'd see a glowing thing.
Gotcha.
This is dark, and it has huge mass, and it's small. That's 3 smoking guns right there.
Right.
Implicating a supermassive black hole.
Supermassive black hole.
Yes. And our black hole is less massive than the one in the center of the Andromeda galaxy, our nearest big galaxy.
Do we have black hole envy?
Well, I think we do. Yeah, some black hole. So, but we're talking about hundreds of millions of times the mass of the sun. But it's a black hole, so it's small for that much mass.
Wow.
And so that's why. Oh, so we do it for our galaxy, then we do it for a neighboring galaxy.
Wait a minute. Go ahead.
And we can't, no, other galaxies are far away, so ground-based telescopes, you can't see it, so we send up Hubble. And so we say, well, if we have it, and we're not really a special galaxy in the universe, and Andromeda has it, our nearest neighbor, maybe, this is astronomy think. These 2 galaxies have it, maybe every galaxy has it.
Right.
Okay? Because why should we be special?
Right.
It's called the Copernican principle. You're probably not special.
Right. Exactly. Copernicus, better known as my father. You're not so special. I don't know what you think, but go ahead.
Your father interacting with you.
Exactly.
Yeah, okay, thank you. So we hypothesize that maybe all galaxies have black holes. So you invoke Hubble, who can see farther away galaxies and measure the movements of stars down deep in the middle, and they were moving fast too.
Right.
And every next galaxy, and so we've now done enough, we're just resigned to the fact that every galaxy's got a black. Even some of the smaller galaxies that might not have, they got black holes.
They still have black holes, right?
So no, we haven't measured every one of the 100 billion galaxies in the universe, but every galaxy we measured, the big ones, the small ones,
it's like taking a poll.
Yeah, except even better.
Right.
Because the universe doesn't have weird people living in back roads who think weird stuff.
Gotcha.
Well, actually, it might. The universe could have some weird galaxy that we've never discovered before.
Right.
Every galaxy that fits into a category of galaxies that we've observed, it's got a black hole of different masses. And the more massive the entire galaxy, then the more massive the black hole is.
Gotcha.
Yeah, there's some that have billions of times the mass of the sun.
Damn.
As a black hole sitting in the middle.
Wow.
Yeah.
We got to stop for a second because I gotta understand something here.
Yeah.
I gotta understand something.